The views expressed on Science for the People are not necessarily the views of this station, its affiliates, sponsors, or advertisers.
This week on Science for the People, we're exploring the ways that science and technology are changing sports, on and off the playing field. Hello and welcome to Science for the People. I'm Rochelle Saunders. With me is Mark McClusky. He's head of operations at Wired.com. He was the founding editor of Playbook, Wired's sports technology blog, and was previously the editor of Wired.com, a reporter and editor at Sports Illustrated and Sports Illustrated for Kids. He was also a member of the cutting-edge baseball analytics collective, Baseball Prospectus, and was a contributor to several of its best-selling books. He's here today to talk about his New York Times best-selling book, Faster, Higher, Stronger: How Sports Science is Creating a New Generation of Superathletes and What We Can Learn from Them. Mark, welcome.
Thanks for having me.
So, sports science is a fascinating field that we don't hear much about, and I assume that's because some of the most advanced research is probably kept in-house to try and give their athletes an edge.
Yeah, exactly. It's in a lot of scientific endeavors, you do your research, you publish your papers, and then the information's out into the world. And obviously in sports science, so much of it is a potential competitive advantage that there's real pressure on organizations not to reveal what they're doing because then the competition can see it. The flip side is that eventually you do have to go out and play the games and you do have to bring the equipment out. And so you can start to see some of these things. There's a little bit of tension there.
It's interesting because I think we should know more about this science. After all, there's a lot here that anyone who exercises or who plays sports regularly would find useful as sort of life hacks. And when you consider all the products marketed to athletes at all levels, I'm thinking gear, supplements, nutrition, and a lot of that marketing makes a lot of claims, some of it backed by science, and some of it maybe not.
Maybe not, indeed. Yeah, it's really, to me, I think that was one of the most rewarding things about working on this book is not just getting to see these amazing things that happen at the elite level, but then really trying to make those connections back to regular athletes. What can more normal human beings take from this very rarefied world and bring back to either their own athletic lives or even their lives outside of being an athlete? I think there are lessons to be learned.
In this book, you argue that we've made massive athletic improvements in the last century, but also that recently things haven't been improving as quickly. Records aren't being broken as often. Are we maybe reaching the limit of what the human body is capable of?
I think anytime you bet against continued human progress, you end up being wrong. So it's, I wouldn't take that bet. I would say, so if you're a mathematician at all, right, you just sort of plot the world records and the pace of improvement, and that curve is definitely flattening out. Does that mean that we are reaching a limit? A mathematician sees a flattening curve and says you're reaching a limit. That's sort of the definition of it. I think that where we stand sort of as a culture and as sort of a sporting culture is we figured out a lot of the easy stuff. And not that it's easy, but the past 100 years have really been a tremendous amount of learning of how the body responds to exercise, what sort of nutrition does and doesn't work, and doesn't work for which sort of athlete or person. The next frontier is not just what works, but why. We know certain things are effective. We don't know some of the reasons why they're effective. And that's a really interesting problem to solve. And then I think the next set of problems to solve is at the very individualized level. What works for me training-wise, what works for me nutritionally, what works for me in terms of matching me as an athlete to a sport will be totally different than for you, or for our friend Bill, or for, a kid in London who, maybe would be a tremendous, American football player, but isn't exposed to the sport and so has no opportunity to show that. I think that those connections start to be the next frontier here.
What else is really interesting is that it was really clear from reading your book how much different people can be adapted to different sports and how different body types lend themselves to different sports and different types of abilities. And you mentioned in your book that this diversity and sort of morphology of different athletes is actually a fairly recent thing.
Yeah, it's, there have been some really great researchers in Australia who've written a lot about this. And they if you go back to the 20s and 30s and look at Olympic athletes, there is much less diversity in the sorts of bodies that you saw in those athletes. Like the male athletes tended to be, 5'10" to 6'2", and in the 180 to 210 range. That was just sort of what an athlete looked like. Now an athlete looks like, taking it to women, somebody like Gabby Douglas, who won the gold medal in London in gymnastics, who's 4'11" and weighs 88 pounds, to Sylvia Fowles, who wins a gold medal in basketball, who's 6'5" and weighs 240. It's that diversity of, as you say, body type, of morphology, really has profound impacts on our performance in these sports. There are physical characteristics that are much better matched to some sports than others. I really like basketball. I'm 6 feet tall and not, you can be 6 feet tall and play in the NBA. You have to be an unbelievably good athlete to be 6 feet tall and play in the NBA. That was never going to happen for me.
So what are some of the ways that elite athletes are hacking their performance? I'm thinking things that maybe the average Joe wouldn't be able to do, or maybe probably isn't worth doing.
Well, I would say that, you mentioned sort of supplementation earlier. For most of us, spending a lot of time and energy talking about nutritional supplementation is not probably really worth it. So I grew up as a bike racer, and I was okay. I wasn't, a world beater. For me to spend a lot of time taking nutritional supplements to increase my biking performance today as a mediocre masters racer is useless. I should, there are much more important things for me to do, like ride more often. So, I think a lot of people will tend to get hung up on nutrition, and especially supplementation. When you're at the elite level, when you've optimized so many other vectors, finding something, an example, beet juice has become a very hot performance supplement for athletes in sort of events from kind of a minute to 10 minutes long.
So now looking at the other side, what are some ways that elite athletes, or some techniques elite athletes use that the average person could probably benefit from?
I think one of the most important things that we can carry out of the elite athletic world is a mindset and a way of approaching problems. And that is, because elite athletes have pushed so far, there aren't a lot of big changes for them to make. And Dave Brailsford, who ran the British cycling program for years, talks about something that he calls performance through the aggregation of marginal gains. And the idea there isn't finding one thing that will make you 10% faster, or even at the elite level, one thing that will make you 1% faster. It's, let's find 10 things that make you 0.1% faster. Let's find 100 things that might make you 0.100% faster. And that if you can just get a little bit better at each thing you're due, at each part of your performance, that those gains really start to add up, that it sort of accrues like interest. When I take that into my life and the people around me, I think human beings are endlessly, A, fascinated by novelty. We don't focus on the things we already know work. And B, we are looking for big sort of quick fixes. I think you see that a lot in dietary advice. Oh, if I just stop doing X, then I'll be healthy. If I start doing Y, I'll be healthy. I think the mindset of no, it's both harder and easier than that. It's harder because you have to work at it, but it's easier because actually if you just get a little bit better at everything, that starts to be real change in your life. To me, that's a very powerful idea, a very powerful framework through which to view your world.
This is Science for the People, and I'm here with Mark McClusky, head of operations at Wired.com and the author of the new New York Times bestselling book, Faster, Higher, Stronger, How Sports Science is Creating a New Generation of Superathletes and What We Can Learn from Them. How much of our athletic ability comes from our genetics, or do we actually know that yet?
So we don't know a specific percentage. I mean, in some ways, everything comes from our genetics, right? Who we are is inexorably influenced by our genetics. It's also influenced by our environment, how we grow up, how we train, what we're exposed to, our economic circumstances, everything around it. Nature versus nurture is one of those canonical scientific debates. And it's no different in the sporting world, especially, after, things like Malcolm Gladwell writing about the 10,000 hours rule and how that applies to sports or doesn't apply to sports. It's, the easy answer here is it talent or training? Is it nature or nurture? And the answer is both. of course, and we actually all know that intuitively, but it's maybe not a little bit, it's not as compelling a story as to say like, oh, you need 10,000 hours of deliberate practice to be expert, and you can be an expert at anything. The strict sort of practice realm, the strict sort of 10,000 hours realm would say that practice is both necessary and sufficient for elite performance. And that's not true, certainly in the sports world. There are plenty of athletes who perform at the very highest level with far less than 10,000 hours or 10 years of deliberate practice. And there are plenty of people who never reach the highest level, even though they spend much more time than that trying to get there. Genetics, we talked about morphology. That's obviously highly genetically influenced. It's got some environmental influences, but if I'm 5'5", I'm not going to play in the NBA. If I'm 7 foot tall, I'm not going to be a gymnast.
It does seem like genetics, just in a very obvious way, does have a lot of pull in certain types of sports and in certain types of athletics. And of course, one of the genetic determiners of your athletic ability is the one we don't think about that often, but we see divide groups of athletes all the time. I'm thinking of gender.
Yeah, I mean, it's funny, right? This statement is slightly simplified. I mean, biological sex is completely genetically determined. It's not always completely expressed the same way. There are intersex and intergendered people who have things that happen, but you have XY chromosome or two X chromosomes. You have that. And we divide competitors along those lines without much thought. Sometimes there are cases that challenge those easy divisions. Like there was a South African runner who is intersex, who does have a higher level of testosterone, but is morphologically female, but in some ways biologically male, and has competed as a woman, has won world championships. But, those are cases that really challenge our entire notion of what sex and gender actually are, which is an interesting thing for sports to do. Contrast that with race. If I were to suggest to you in this interview that we should have a world championship for athletes of African heritage and a world championship for Caucasian athletes, most of us would find that offensive. And it's an interesting way to remember that we get very comfortable with some lines and are very uncomfortable with others, and need to sort of examine the thinking behind both of them.
In some cases, and I'm thinking again of the South African runner, we hear that people get tested or that there's controversies because some of these people might have, and I'm using air quotes, unfair advantages. But are these really unfair advantages? I guess someone just won the genetic lottery in that particular case.
In that case, well, I mean, and that's an extreme case, right? But my grandfather always said life isn't fair, and it if you want to go sort of to the absurd level on this argument, if every competition was perfectly fair, nobody would ever win, right? It would be a tie for first place, and we'd all get participation medals and be fine with that. Some people do win the genetic lottery. Some athletes have the ability to process more oxygen than others, just on the day they were born. Some train really hard to express that ability even more so. Some have a lower inherent ability and express it. Richard Lewontin, who's the biologist and geneticist, has this great metaphor for it, which is genes are the size of the bucket, the potential, and environment is how high you fill that bucket. So, you might have a bigger bucket than me. You might have more potential, but if you don't work to express it, my smaller bucket, I might be able to fill higher and still beat you in a setting like that.
I've heard that women athletes, in terms of breaking records, are actually currently improving faster than men. Is that true? That
was the case for a while, especially through the 70s and 80s. And really what you can point to is the massively increased participation of female athletes in sports during that time. Things like Title IX in college athletics really, really expanded the opportunities for female athletes in the United States and abroad, because our intercollegiate system draws so many athletes from around the world. The percentage of athletes in the Olympics, the male-female ratio became much closer to 1-to-1. And so there's just much more opportunity for female athletes, and as you sort of bring a bigger population to bear on an event, you're going to get increased performance. You have a better chance of finding the best possible performers. That rate has really sort of normalized. Female world records are not outpacing, the improvement in female world records are no longer outpacing the improvement in male world records.
Are there sports where the gap between male and female competitors is quite small versus other sporting events where they're larger?
The general rule, and this is a very general rule, is in endurance sports, the longer the event, the closer the gap. And in some ultra-endurance running events that are 100 miles, 150 miles, women have actually won those races against male competitors at a very high level. Strength sports, those gaps are pretty profound. I mean, just the difference in our biology and the difference in testosterone, those anabolic agents. That's why steroids were so particularly effective for female athletes in the 70s, because there's so much. They don't have the testosterone in their bodies, and so you're able to really radically increase strength through that treatment. Those sports, you're never going to see the gap close to the same extent. Things like the 800 meter and the 1500 meter swimming events have the smallest gaps in swimming. Longer track events have smaller gaps.
You're listening to Science for the People, and today we're talking about science, sports, and elite athletics with Mark McClusky, head of operations at Wired.com and author of the New York Times bestselling book, Faster, Higher, Stronger, How Sports Science is Creating a New Generation of Superathletes and What We Can Learn from Them. One of the things you talk about in the book is on the road to becoming an elite athlete, whether it's better for someone to focus in on one sport early or whether it's better to branch out more when you're younger and focus in later. Can you talk a little bit about what you found there?
Sure. I mean, broadly, more athletes make it to the elite level through what's called late specialization, that they play a lot of sports growing up, that they sample a lot of things, that they try different sports, and that's a huge thing. Again, I'm a real believer that the very best athletic performances are the result of great genetic ability, great effort, and great sort of match between an athlete and their sport. So flip it the other way. Think about early specialization. I have if I had a 10-year-old boy and I decided he's going to play baseball. Baseball is the sport that's all he's ever going to play. Maybe he'd be a great soccer player, but he'd never have a chance to know that. He'd never have a chance to even know if he liked playing soccer. So it's not that early specialization can't be a path to elite performance. And, everybody will point to, Tiger Woods started, playing golf when he was 2. And, there are lots and lots of stories that we all sort of know on kids who got very focused very early on a sport and played it to the exclusion of everything else and were successful. And it certainly works. But you can do the research and look at the broader population of elite athletes, and the data is very clear that it's a more prevalent path to have a broad athletic experience as a kid than a very focused one.
Is there any idea of why that is?
There are several. I mean, there are several factors that I would point to. One is, if you hate playing a sport, you will not succeed. Right? And, Andre Agassi, if you've ever read his autobiography, it's a spectacular book, and he spends a lot of the book talking about how much he hated tennis. And he hated tennis because his father was an incredibly demanding person who, from a very young age, demanded that Agassi play tennis all day, every day, and really do everything he could to be a great tennis player. It worked. He was able to push through that somehow, and frankly, I don't know how, because most kids, when confronted with that situation, will just stop playing. And let's remember, statistically speaking, anybody listening to this, your kid is not going to be an elite athlete, right? Obviously, somebody becomes an elite athlete, but statistically, it's an incredibly small proportion of the population, a vanishingly small proportion. And so to be sort of approaching this, let's say as a parent, thinking I'm going to raise an elite athlete and I'm going to go through these steps to do it, you're almost certainly not going to. And what you are massively more likely to do is create a kid who hates sports or who hates a particular sport that you push him or her into. So that's one factor, burnout. The other factor, as I said, is not just that match of sampling different sports, but also you do have generalized athletic abilities that you develop across the different sports. Steve Nash, the great point guard, grew up playing soccer, and he really credits having played soccer with giving him the unbelievable court vision that he had as an NBA player. He saw things differently than other point guards had. He changed the position, and if you ask him about it, part of what he will tell you is he saw it differently because of the decade he had spent playing soccer as a kid. He just thought about space differently than basketball players typically do. Being able to transfer those abilities from one sport to another is a fascinating thing.
Does someone's performance as a young athlete tell us ultimately how they'll perform as an adult?
Not as much as you would think. A lot of the people who I talk to in my book are people who run places like the Australian Institute of Sport or the U.S. Olympic Committee developmental programs or UK Sport in Great Britain, where they're trying to identify and work with people who have the potential to win Olympic gold medals. There were some interesting studies done that, between, let's look at every runner who competed in the finals of a junior world track and field championship, and let's see if they made it to an Olympic final. And something on the order of 25% did, which is a lot. So in one way, that's an incredibly good predictor, right? Like having an instrument that tells me that 25% of these people will make it to the Olympics, that's a great predictor. I guess I'm more interested in the 75% who didn't. The people who were not great junior competitors who become great senior competitors. And there is some research that suggests that the very best senior competitors tend to mature later and tend to have not had great junior careers.
It's interesting. One of the things that I found most surprising in your book was how some of the Olympic committees from around the world actually try and recruit people into sports where they're not winning very many medals and actually turn around some medal-winning performances in only a couple of years.
I love this. So one of the sort of case studies that I talk about in my book is a woman named Helen Glover who won a gold medal in London in rowing. So she first rowed in a boat about 2.5 years before the Olympics, which, is kind of crazy, but awesome too. So what UK Sport did in the run-up to the London Olympics, they launched a program, and I love the name of this. They called it Sporting Giants. Basically, they put out a call for athletes. They said, if you are 5'10" or over and a woman, or 6'3" and over and a man, and have been a competitive athlete at sort of the county level, which, is kind of like the state level here in the U.S., we'd like to talk to you. And they got about 1,000 athletes responded to this. And what they were looking for, there are a couple of sports where tall is really important, and rowing is one of them. It's a physics problem, basically. Rowing coaches talk about tall people as having long levers because you're pulling the oar, and the taller you are, the longer lever you are in comparison to the oar, and the faster you can move it, or the more you can move it further per stroke. So Helen had been a field hockey player and had played at sort of the county and a little bit higher level. She'd never been an international field hockey player. And she went and she signed up for this program, and she went and did some physiological testing, and they found out that she was an incredible aerobic athlete as well. And they started training her as a rower, and 2.5 years later, she was listening to God Save the Queen on the top of the medal stand. It's a testament to some very clever thinking and recruiting by the UK sport people, which is to do what's called talent transfer, to take athletes who might not be having super elite success in one sport and find ways to move them into a sport where they might have more success.
So from the standpoint of cutting-edge sports science, what are some examples of stuff that's right out there on the edge of what's possible?
To me, some of the real frontiers, as I said, are in personalization. Not just let me design a nutritional program for you based on the sport and based on your caloric requirements, but let me be doing blood testing all the way through. Let me be looking at the levels of various micronutrients, things like vitamin D, things like creatine, which can be a marker of muscular damage, things like your testosterone levels. Let me do everything I can to find a way to support you nutritionally that is really at an individualized level. It's really hard to do. One person in nutrition basically said, we're 20 years behind a lot of exercise physiology. We're still figuring out some of these mechanisms. We're still figuring out some of these energy cycles and how to really affect them with nutrition. So to me, that's one. Another one for me is really going very, very deep in the data of your performances, of your training and your performances, and looking for, as I said, those really marginal gains. If I train in the morning rather than the afternoon, do I get a better adaptation eventually? If I train in longer bursts or shorter bursts, it's a constant science experiment at this level. It's a constant feedback loop. But our ability to capture so much more data than we had in the past, and then be able to analyze these, oceans of numbers to come up with real insights that you can act upon, I think is a fascinating thing.
I really like the idea of elite sports being a sort of science experiment you can do on yourself. That's a really interesting idea.
Yeah, it's in the book I talk about N equals 1, for the scientists in the crowd, N's the population. And usually you do a study, you try to get as many people. Elite athletes are rare. They aren't a usual population, and each one is a little bit like a snowflake, right? Each one is pushed very, very far towards the limits of their ability, has not a lot of easy gains, but if you can get into that experimental mindset, which is hard because you're asking an athlete to question things that have gotten them to a very high level. So it's a real balancing act. It's a real balancing act between the scientist and the coach and the athlete. The scientist might have 50 things they want to try. First you've got to translate that through the coach. Can you even make the coach understand that? What's the risk reward for each of those? Because, you have to be a little bit, first do no harm about it. You can't cause someone to regress. That's a problem. And then, how do you break a lifetime of training and habits to actually implement those things with the athlete? It's a very ticklish process.
You're tuned in to Science for the People. I'm Rochelle Saunders, and I'm here today with Mark McClusky, operations manager at Wired.com and author of the New York Times bestselling book, Faster, Higher, Stronger. So in this sort of cutting-edge science for sports, I feel like there's this gray zone where some of it's cutting edge and some of it is maybe in the murky territory of being cheating, and I use air quotes because it's really hard to say in especially elite sports what is cheating and what isn't, and what is in the rules performance enhancements and what's kind of out of bounds.
It's an interesting problem. A quick example. So more red blood cells are incredibly useful for an endurance athlete. You can deliver more oxygen to the muscle and you can continue your effort for a longer period of time. So one way to have more red blood cells is to live and train at altitude, which people have been doing. That really came into vogue in the 60s and 70s. There's less oxygen in the air and your body adapts by creating more red blood cells, and you go to sea level and you have more red blood cells. That's great. We're all comfortable with that, right? That doesn't seem like cheating to most of us. So take it a step further. What if I want to live here at sea level but sleep at altitude? And so I can build a tent in my house that basically sucks, it's called a hypoxic chamber. It creates a lower oxygen environment for me to sleep in. So is that cool? Well, they're not banned. There's been some conversations about them being banned, and is this basically technological doping? Okay, so let's set that aside. Then there's blood doping. Like, what if I take blood out of my body, spin out the red blood cells, and then inject it back into my body before a competition? That's banned. It's got net some of the same effects. It might be a different amount of that effect. What if I take your blood and put the red blood cells in my body? I think people are even more uncomfortable with that. And then what if I take a drug like EPO that does the same? All of those things increase the number of red blood cells in my body. Some of them we're comfortable with and some of them we're not. To me, the lines, as you said, it's a really hard thing to figure out where the lines are. I think a couple of things stand out for me. One is I think people tend to get really uncomfortable with things that they feel like distort what the competition is supposed to measure in their mind. So when there was this boom in swimsuit technology around the Beijing Olympics, and these super swimsuits, and every swimming record was destroyed, and a lot of people were like, oh, it's just the swimsuit. And it felt like suddenly the competition was like who had the best suit and not who was the best swimmer. And they were banned because of that. Contrast that with Formula One, which is a competition where we're very happy with like technology being in some ways the main vector along which the sport is fought. The drivers are incredible athletes and super important, but like the best driver in the world in a terrible car will never win a race. So it's those moments where it feels like the competition has been sort of subverted or changed, I think is where people get most uncomfortable.
There tends to be kind of a sliding scale, I think, just looking at the sports and what's considered to be improper performance enhancement versus, within the bounds, where technology is kind of integral to the sport being done. I'm thinking in things like cycling, technology kind of gets a pass a little bit, or it's a little bit more loose around the rules, whereas swimming, where technology isn't really integral to the sport of just someone swimming in a pool, I feel like technology is sort of frowned upon a little bit more.
I mean, I think that's true. Cycling is obviously, as I said, sort of near and dear to me because it was my sport. There are rules around equipment in cycling that are sort of, a cycling frame has to have that sort of double diamond shape, according to the rules. It has to be a certain weight. I mean, there are rules that really stifle innovation. It makes cycling a little more akin to stock car racing than Formula One in some ways. Stock cars, a part of the idea is that there's less to futz with in the car. I think people would be perfectly happy to watch bike races that push the technological envelope further. I think what the international cycling governing bodies have done is tried to standardize a little bit to keep that balance where they think it should be.
There's also, of course, safety concerns in some sports where technology restrictions are put in place to protect the athletes as much as they are to protect a kind of fairness. I'm thinking the story you told in your book about downhill skiing.
Yeah, so in downhill skiing, they changed the rules for how aggressive the shape of the ski could be. So the more aggressive the side cut, the curvature on the ski, the faster that ski turns. And the international governing body changed those rules to basically make the skis harder to turn in some ways. The idea behind that was to try and protect the knees of the athletes. They thought that if they could lower the turning radius, that they would reduce the stress on the athletes' knees and make it a safer sport. There's some real questions on whether or not that's true. What there isn't a question about is, for some skiers, that was an amazing thing because the new skis really suited their style. And for some skiers, it was a disaster because the new skis completely didn't suit their style. So Ted Ligety, the American skier who just won another world championship and won gold in Sochi in the giant slalom, became the dominant giant slalom skier of his generation, certainly, and maybe of any generation after this ski change. The irony is he was incredibly vocal in how much he hated the new skis and the ski change, but they perfectly meshed with how he skis. He tends to initiate his turns much higher on the hill and carve them longer, and so it was great for him. But it's funny talking to him about it. He recognizes, this has worked out great for me, but I really hate skiing on these skis sometimes.
A friend of mine and I were joking around, and I was telling him about this book. He mentioned that as a sort of thought experiment, it would be interesting to have an Olympic-like sporting event where drugs were allowed and all technologies were allowed rather than banned, just to kind of see what the human body can do at the greatest extremes. Now, that's a hypothetical, and probably there are some health and ethical concerns with that, but do you think we'll ever see a split in sports where on one side we have the clean people, just the sort of raw human body, where in the other arena we might have a sort of no-holds-barred augmented human sporting, whether it be technology or drugs?
People have certainly suggested, so there's a classic Saturday Night Live sketch where it's the all-drug Olympics and basically a weightlifter is trying to heave up this giant set of weights and he rips his arms off. They stayed down with the bar and his body's so strong he tears itself apart. It's an argument I've made in the past, let's let anybody do anything. I don't think that works in and of itself, and here's why. I think people tend to think that levels the playing field, except it doesn't. Just like anything else, we have very individual reactions to performance-enhancing drugs. So for some athletes, they see huge benefits, and some they see much less. If I have a higher natural level of testosterone in my body than a competitor, and then we both take testosterone supplements, like, he's going to see a better increase than I do. It just changes where that unlevel playing field is. It's about who has the best pharmacology now. Look, historically, human culture has wrapped its head around gladiatorial spectacle in ways that probably don't reflect super great on us. And so I wouldn't say it'll never happen. I don't know that ethically and morally we're ever going to get there. I think you even look at what's happening in sports like the NFL and NHL today around concussions and the real conversations that are being had around that. I think societally we are much more in tune with the toll that these sports take on athletes and their bodies and their lives. And so while it seems easier to sort of be like, do whatever you want, it's up to you, it's your decision, I think that argument is increasingly difficult to make when we see the ramifications even of sports that we play now with these rules, and what happens to athletes after repeated high-speed collisions, what happens to them after putting their bodies through the things that they put them through.
What about when we talk about athletes or people who are disabled in some way, but with new technologies that are coming out, may end up with prosthetics that maybe give them an edge that a real leg or a real foot doesn't give them? I know there was previously some controversy around some runners who had some prosthetic limbs about whether or not it was fair for them to compete in certain types of competitions. It's
going to be a really fascinating frontier. You said augmented humans earlier, and that's an interesting way to think of it. I'm going to answer your question in a roundabout way. At the end of the book, I'm talking about the limits of performance, and I was down, Red Bull, the energy drink manufacturer, has a huge sports science department and program. And I was talking to the guy who runs it. His name's Andy Walsh. He's a very well-known sports scientist. And I said, nobody's ever going to run 100 meters in 6 seconds. Nobody's ever going to run a marathon in 20 minutes. And he looked at me. He's like, well, sure they are. He's like, they might not look anything like we think athletes look today. And that's a really radical notion, and I kind of love it. But if you look from Neanderthal man to today, and what's happened in that course of time, think of the difference in performance. If you look at even the difference in performance in the 130 so years that we've taken sports seriously, there are huge differences in performance, and you start to project that out 500 years, project that out 1,000 years. What does that look like? It's a really interesting question.
Mark, thanks so much for being here. It's a really fascinating book.
Thank you.
You can learn more about Mark McClusky and his book, Faster, Higher, Stronger, How Sports Science is Creating a New Generation of Superathletes and What We Can Learn from Them, at the website McClusky.com, a link which we'll have available for you in the show notes for this episode on our website, which is scienceforthepeople.ca. After the break, Desiree digs into the science of supplements with Dr. Bryan Chung, founder of the blog Evidence-Based Fitness. Stay tuned.
Science for the People is a weekly radio show exploring everyday life from a scientific perspective. To find out where Science for the People airs near you, or to listen to past episodes, check out our website at scienceforthepeople.ca. You'll also find links to connect with us on Facebook, Twitter, and Google+, or to subscribe to the podcast in iTunes. And now, back to the show.
Welcome back to Science for the People. I'm Desiree Schell, and I'm joined by Dr. Bryan Chung to talk about sports supplements. Bryan is a plastic surgeon specializing in hand and wrist surgery at the University Health Network in Toronto. A research methodologist by training, his main research interests are the design and reporting of randomized controlled trials, as well as measurement tool development and validation. He blogs at Evidence-Based Fitness, a site that critically examines research topics in fitness and nutrition. Thanks for being here, Bryan.
Thanks for having me.
Now, what is a sports supplement exactly? Is there a proper definition?
I think there probably is a proper definition out there. I can't really say that I know it off by heart. I think supplement by definition is something that is quote-unquote extra, that sort of lies outside of regular solid food and drink in a sort of colloquial sense, because I think people consider whey protein to be a supplement, even though it's technically a food, right? So I generally take a more practical definition of supplement versus maybe the official definition, which I would have to go look up.
I see a lot of words like creatine and beta-alanine and glutamine, and those are the things that companies claim will make you bigger, stronger, and faster, for lack of a better word. So let's go through them. What is creatine?
Creatine is a substance that is normally found inside your cells. You get it from food. You can eat a large steak and get a fair amount of creatine. It's found in animal protein mostly, but also present in some plants. Its supplement function is basically to draw water into the cell and to make the cell larger. How it actually goes about producing the sort of the strength effects. And now there's a lot of other research coming into creatine use, which has to do with mental function, particularly in some disease states that we don't really fully understand. So we don't totally get why creatine does its job still. We just know that when it's put to the test, in terms of a cell volumizer, that it does tend to produce pretty good results in some people. And there are some people who are creatine non-responders, but we do see they're not large effect sizes, but they're pretty good effect sizes for something that is quite cheap and easy to take, and has virtually no side effects and no real adverse effects.
What about beta-alanine?
I would say beta-alanine is still pretty controversial. It is one of the precursors to carnosine, which is a substance that's found inside your cells. And beta-alanine gets together with another molecule, the name of which I can't quite remember right now. And they get together and they make carnosine inside the cell. And carnosine basically is associated with decreasing fatigue in the muscle cell. So theoretically, if you take beta-alanine, you can increase the level of carnosine in your muscle cells, and therefore you don't get tired as quickly when you exercise. That's its purpose.
Now, I noticed you said theoretically.
Yeah, so that's biochemically what should happen. The problem is that when you test it in humans and you say, does this actually make you, say, run faster, longer, are you stronger? When you put it to the test at the doses that people are given, my personal feeling is that the effect size is really small. The hype is definitely greater than the effect that it's attributed to.
And how about glutamine?
Glutamine is an amino acid. So also just found in your body. You can see where the common sort of theme is with most of these. They're things that you find in your body, right? It's one of the many amino acids that you find in your body. And amino acids are the building blocks of protein. So anytime you have like a steak or even plant protein, they all have amino acids in them. Right? They're all made of amino acids. So glutamine is used medically sometimes to prevent muscle wasting. And I think there are some uses of glutamine in terms of people who have like really bad stomatitis, which is like sort of really bad ulceration of the mucous tissues inside your mouth and your upper digestive tract. And so as a sort of extension of that, glutamine is touted to have recovery effects in terms of helping you recover faster from training.
You don't sound convinced.
Well, again, like it just, for a lot of these supplements and a lot of the things that are sold on the market, that when you actually delve into the research, you find that the quality of study is usually not very high. The number of people studied is also usually not very high, and it's hard to find really good concrete evidence to really hang your hat on and say, yeah, this is really worth using. I would say the only supplements that have really passed that test would be creatine and the use of supplemental protein, which you don't have to use whey protein. You could just eat more, but it's sometimes just hard to eat that much protein because it's so much solid food. With all of the other supplements that are out there, there's not really a huge amount of evidence to show that any of them are really that effective at doing what they say they're supposed to be doing.
Okay, well then let's break this down a bit. Do these kind of sports supplements help athletes?
There are supplements where the effect size, like the size of the effect, might benefit a really elite athlete. If you're a sprinter, like the 100-meter sprinter, and you want to win a gold medal at the Olympics, you have to do 100 meters in less than 10 seconds, and it's encroaching on the 9-second limit. And so if you took something that improved your sprint performance by 0.5 seconds, that might make the difference between you getting a gold medal and nothing.
Right.
If you're just you and me, and my sprint time improves by 0.5 seconds, that's the difference between nothing and nothing. It doesn't give me any gain of anything unless we're running away from bears, and that 0.5 seconds is what makes me the faster person, right? When we say, does this make a difference for athletes, it really depends on what the scope of the effect needs to be and whether that scope of effect can be achieved by that supplement. That being said, I am not entirely certain that there are any supplements that would help an elite athlete go between gold and not gold, right? But I think that's the level at which things need to be discussed, and that's the level at which you also need to look when you're looking at these studies. It's also looking at, well, sure, they studied a bunch of college athletes to look at this supplement. Who's taking this supplement? It's like people who are in their 30s, late 20s, who aren't even doing this sport. They're in the weight room lifting weights, and this study isn't looking at lifting weights. So is it effective has mostly to do with who are we talking about and what are they doing and what is that effect, right? So a lot of weightlifters are taking beta-alanine, but there's no evidence to show that it actually lets you lift longer in weightlifting.
This is Science for the People, and I'm talking to Dr. Bryan Chung about sports supplements. How about those people that are working out sort of 3 to 4 days a week? They are not doing intense bodybuilding. Is there any reason for them to use sports supplements?
Yeah, there are. Again, depending on how you classify supplement. So if we think of whey protein as a supplement, I'll just put it there because that's how most people buy it. They don't really, I mean, some of the grocery stores are starting to sell protein, but for the most part, you go to a supplement store to buy protein. So yeah, I think there is a role for that. Again, depending on what the effect it is that you're looking for and where you're trying to go with your training, if you even have a goal or if you're just going for fun and just sort of to maintain what you have. And it also depends on whether or not you are achieving what you want to be achieving and whether you have everything else kind of in check. So if you're going to the gym 3 to 4 days a week and you're just trying to lose some weight and your calories are under control and you think you would benefit from having a little bit of extra protein, then there probably is a role for taking a protein supplement because it's an easy thing to take and you don't have to sit down and have a steak to have that amount of protein in your diet, or you don't have to have a chicken breast, which, is not an insubstantial amount of food for some people. So having the luxury of being able to just chug that back and have that protein and know that you sort of have that dose roughly of protein is of benefit for some people.
Well, how much protein do you actually need to help your body at 3 to 4 times a week?
So that question I think has yet to be answered. 3 to 4 times a week, if you're just sort of trying to stay in shape as opposed to achieve, some sort of a large fit, like not large, but you're trying to achieve a higher fitness goal in terms of pushing your body towards something that it doesn't just sort of naturally stay at, right. Then, protein requirements roughly fall in the sort of 1 gram per kilogram of body weight per day. So, you don't need a lot, and you might not even need a protein supplement to hit that. And even that's on a little bit of the high side. Like that's still, it's kind of for a quote unquote athletic population. And I think if you're working out 3 to 4 days a week, you probably sort of fall loosely into the athletic population. The bar's not very high.
Thankfully. So how would supplements affect you if you're not doing any exercise at all then? With a protein supplement, for example.
Then you're just drinking calories that still go towards, you're just drinking protein that still counts towards your calorie count for the day. And most protein shakes are not that great tasting that you would prefer them over something else, right? So
what if you're a vegan, for example, and you're not getting enough protein in your own diet?
If you're not getting enough protein, then you're not hitting baseline levels. And so then using a protein supplement might be helpful because there are vegan proteins out there that are able to do that. And so that could be helpful. I mean, I think if you're a vegan and you're not getting enough protein from your food sources as a baseline protein, like you're actually becoming protein deficient, then I think you probably need to examine your own vegan habits. Like you should be able to meet, even the Health Canada reported protein requirements on your food.
Well, I don't use supplements, but I know an absolutely ridiculous amount of people who do use supplements. So I crowdsourced some specific questions about specifically protein supplement use. So for maximum impact, should you take the supplements before or after exercise?
That also depends on the supplement. By and large, because I don't think, other than the two supplements that I've already mentioned, that the other supplements are really worth taking at all, then for the most part, most supplements, it doesn't really matter when you take them. The ones that are designed to help you increase workload in your workout obviously need to be taken before. And I don't know that there are any that you must take after. So there's not really, there are some studies looking at protein timing, like do you take it before, during, or after your workout, how long after your workout, and that sort of thing. But most of the researchers that I would talk to, and I'm going to make a wild stab at whether they would agree with me or not, is that the effect of timing is far less than it's given credit for. There probably is an effect, but to have to obsess about that timing is not necessarily going to give you the benefit that you think it's going to give you.
Now, this is a very specific question. What is the best supplement for a skinny guy to get bigger if he's lifting weights and doing cardio 3 times a week?
That's a very complicated question. So the skinny guy who's lifting weights and doing cardio 3 times a week, there are some trainers and some schools of thought that would say if you're trying to gain mass, that doing concurrent cardiovascular workouts is maybe not in your best interest, because you're expending energy that could be used towards accumulating more tissue. And therefore you still have to make up that stuff that you're burning away. And so this idea that you can lift weights to build muscle and then do cardio to lose fat, it still comes out of the same energy pool. And so if you're still coming out at the end of the day as being negative in your calories, or substantially negative in your calories, that you're probably not going to make a lot of gains on the gaining side of things, because the energy to make the new tissue might not be entirely present, even though the training stimulus is there. So if I take that question as it is, then I still think a protein supplement is going to have the biggest impact, because it's going to count towards your calorie pool. Because you are more active, your protein requirements may be a little bit higher, depending on what your baseline protein intake already is. And so that's sort of, it all depends on where this person is with what they're doing and what needs to be changed. And so there's not really a good general answer to that, but I'm just going to say protein to be safe.
Is there a law of diminishing returns in play with sports supplements? Can you plateau and then stop seeing results? Can you bottom out on the protein scale?
Yeah, I think with anything that you do, you're eventually going to outscale it, especially if the administration of that supplement is exactly the same dose, frequency, right, method, all of that. If that all stays the same, then yes, you will eventually outclass your supplement, just like with a drug, right? Especially because with a supplement, you're generally trying to get better and better and better and better, as opposed to a drug where it's sort of, we're trying to just hit a level. And if we hit that level, that's what we say is where that's where we're going. So if you're taking a blood thinner, we look at your blood clotting and we say, okay, your blood clotting number needs to be between 2 and 3. And so even though it's going to take 5 times the dose to get your blood clotting number to 4, we're not interested in getting it there. We just want you to be between 2 and 3. With supplements, it's a little different, because people don't necessarily have a stopping point. They don't have a point where they go, that's where I want to be and that's all I want to do. They hit that initial goal and then they want to keep going. So at some point, yes, you're going to outstrip what it is that you're taking. Caffeine's a really good example of that. So, because you eventually develop a caffeine tolerance and you need more and more caffeine to get the same effect, right? So if you stayed at the same caffeine dose and you were taking it regularly, either for like a cognitive benefit or for an athletic benefit, then eventually you need more caffeine to have that same benefit. Right. And so you do plateau the caffeine. And so that's a perfect example of how a supplement just stops working.
So are there any long-term negative effects of supplement use?
I think there can be. I think some of them are knock-on effects. They're not direct harmful effects of supplement use. So one way that I can see supplements sort of going wrong is when you start depending on your supplements and really investing your effort into your supplements and making your supplements the mainstay of your efforts, as opposed to being what they are, which is supplemental, right? They're supposed to be extra. They're not supposed to be the main part of everything. And so if you're starting to obsess about how many bottles of everything you have, then I think that is a knock-on effect. That's a knock-on adverse effect of supplement use, where you start thinking that they're essential to what it is that you're doing. In terms of actual side effects, those are always possible. I think the beta-alanine tingling thing is one of those things that happens, and people get like tingly legs or a tingly bum, and that's not very pleasant, but I don't know that that's harmful necessarily. Long-term use of most supplements, I'm not aware of any significant long-term effects, although we're not that far into the age of where supplement use has become widespread. So we're not yet in the area where we have seen people who have been on supplements for a really long time. And a lot of supplements that are on the market now haven't even been out for that long. So beta-alanine, I think, has only been out since the mid-2000s, so not even 10 years yet. Right. So we don't know what happens when somebody takes beta-alanine chronically for 20 years. So
the answer is we'll see?
Yeah, I think so. So far, nothing has really come up. There are some case studies with people who have pre-existing diseases, or they discover they have pre-existing diseases that have bad effects on supplements. Those are really difficult to predict, and there's not really a way of knowing who's going to hit, especially if you don't know if you have a pre-existing disease, right? So if you didn't know you had some level of kidney failure and supplement had an adverse event on your kidneys and therefore caused your kidneys to fail even further, that's a totally different animal of long-term effect use or even short-term effect use, right? But outside of that population, because that's a really dicey area to wander into, I think, for this interview, outside of that area, I haven't been aware of any adverse events for long-term chronic use of most supplements. And then the other adverse event is basically your pocketbook, right? So you're taking these supplements that don't necessarily have any proven benefit, and you're spending money on them, you're spending effort, and you're spending energy on them for possibly no accruable benefit.
One last thing. Can you tell us about Examine.com?
Yeah, so I'm on the board of advisors for Examine.com. It's an independent website. It makes money primarily off of selling supplement review guides, basically. It doesn't accept any funding from any other sources that I'm aware of. And it's basically an impartial research review website that is pretty comprehensive in terms of not only the number of supplements that it reviews, so it branches out into even areas that of supplements that most people don't even consider as supplements. And also it's quite comprehensive in terms of its review of the research of the studies that have been done on that particular supplement. So, for your listeners, if they're either taking something that they're not sure that they should be taking, or are just wondering whether they should be taking something, it's actually a really good lay resource for people who just have questions about supplements.
Bryan, thank you very much for being here.
No, thank you very much.
And we've linked to Dr. Bryan Chung and evidence-based fitness on our website at scienceforthepeople.ca. You'll also find links to connect with us on Twitter, Facebook, Google+, and iTunes, where you can listen to past episodes, subscribe to the show, or leave a review. Thanks for listening, and we'll see you next week on Science for the People.
Science for the People is recorded in Edmonton, Alberta. The show is produced by Rochelle Saunders. Ryan Bromsgrove is our promotions manager. Our social media manager is Chelsea Butler. K.O. Myers updates our website. Helen Quivalon is our publishing liaison. Ed Haynes is our guest coordinator. We get research help from Josh Whitten. The show is edited by K.O. Myers and Ryan Bromsgrove. Our theme song was written and recorded by Fractal Pattern, and its title is Binary Consequence. The show is hosted by Rochelle Saunders, Marie Claire Shanahan, and me, Desiree Schell.